This is a video demo showing how you can use PVCAD to design a commercial solar project. I can tell that PVCAD was properly installed because I can see the PVCAD ribbon across the top of my AutoCAD. The first thing you want to do when you start a new project is set the location using the Set Location button. From here, you can either choose Map to load a map or File if you want to load your location from a KMC file, Google Earth file. In this case, I'm going to show loading my location from the map. I just enter the address of my project in that top level window and it pulls up a map with the project location. You need to pick the units you want AutoCAD to use in the drawing. Once you've done that, you're going to click into the drawing to tell AutoCAD where you want that georeference point to be. And then that little red dot represents the map coordinate that you chose, or the map address that you chose. As you can see here, we have a commercial building. There's actually a few different roofs. In this example, we're going to put solar on that top roof, the north side roof. But we're actually going to draw both that roof and the roof below it, because as you can see, the roof below it is actually taller. It's casting shade on top of the lower roof. This is a really cool new feature in the latest version of PVCAD, where we can really model shade with a high level of detail and see which solar panels are going to be impacted by the shade of the upper roof onto the lower roof. The other thing you can see me doing here is just drawing any obstructions on the roof. So if there's any vents or HVAC units or skylights or antennas, whatever have you, that might also cast shade onto the modules. If we draw them, then we can model them as well and get a really good shade profile. In PVCAD, we call all of these things obstructions, and obstructions can have properties of both setback and height. And when you put in the height, it'll use that to calculate the shade. The next tab over, we have something called version settings. This is mostly electrical settings. We can specify some things about our tie-in panel. And then we go to mechanical layout. This is where we actually create the solar panel layout. So I'm going to pick the racking manufacturer, the specific racking I want to use, the module manufacturer, and the specific module I want to use. And then I can click into my roof, and it'll do a layout on the entire roof using the spacing of that particular racking and module combination. Now for this example, because the taller roof doesn't actually have any solar panels on it, I'm just going to define it as an obstruction. I'm going to give it a height, and then it'll cast shade onto the shorter roof. And then I'm also just adding a tree here on the side, just some more shade objects to make our shade seem more interesting on this project. And then I'm just going to run this shade analysis by clicking the shade analysis button in the top level menu. And then you can see the software is going to calculate the TSRF, or total solar resource factor, for every single solar panel on that roof and color it accordingly. And then we can also download a report from the software to see in more granular detail exactly how much shade loss we have on this project. Okay, now that we're done looking at shade, we'll move on. I'll show you some of the electrical features of the software, where we can generate single line diagrams and do things like calculate wire size, breakers, voltage drop, conduit fill, blah, 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 blah. All the electrical features of the software. So the first thing I need to do is pick an inverter I want to use for my project and place it somewhere inside my drawing so it knows the actual physical location of that inverter. It's going to be important later on when we do voltage drop calculations. And I can have multiple inverters. I can also insert something called an AC panel. So that's like a combining panel, where if you have multiple inverters, you want to combine them into one circuit, as well as what we call the main panel, and that's the tie-in panel, where everything ultimately aggregates at the tie-in panel. The next step is going to be to select a string length and string the modules in the array. Once I've grouped all the solar modules into strings, the next thing I'm going to do is select individual strings and then click on the inverter that I want to connect those strings to, and thereby associate each string with an inverter. Similarly, I can associate each inverter with the AC panel it connects to, and each AC panel to the main panel by using the AC circuit conductor button, and then clicking on the inverter, clicking on the combining panel, click on the combining panel, click on the main panel. Once I've done that, I've completely defined my single line. So all I need to do is click the single line diagram button on the main menu, and the software will generate the entire single line drawing for me. As you can see, the software is going to fill out all these tables that show you the module you chose, the inverter, conduit size, wire size, breakers, voltage drop, all the math is done for you basically in one click by the software once you've told it which items are connected to each other. Because the single line is built using AutoCAD blocks, you can easily make manual changes by changing the visibility of the blocks or redrawing the blocks to better suit your drawing standards. Then I can click the Build Materials button and export the build materials for my project to an Excel file. The final feature I'm going to show here is our Export to PVsyst feature. So to activate this feature, I'm going to pick the PVsyst button from the top level menu, and this will cause the software to save the PVsyst compatible file onto your computer. Then if I go in and launch PVsyst, I can then, from PVsyst, find that project and load it into the PVsyst shade scene. And then I can get the full shade scene of the building that I modeled in PVCAD inside of the PVsyst environment.